Systems of equations. All right, now just by looking at these, you can tell how many solutions they have. The first one is a quadratic and a line. All these are quadratic and linear. So, whoop, right there and right here, there's two solutions. Solutions, when you have a system, are where these graphs touch. Now this one, your teacher tried very hard to draw it where it only touched once. One solution. Now, if you have a system where the lines never ever touch, oh, you guessed it, no solutions. All right, now, if you have a quadratic and a quadratic, that's two parabolas, and same idea, the solutions are where they touch. So here's a solution and here's a solution. This one has two solutions. One of them is at -2, 3, and the other one is at 2, 3. All right, just ordered pairs. This one just touches at one spot, so it has one solution. And these parabolas over here, they don't ever touch, so they have 0 solutions. Now, the first one in red is an example of one line overlapping another. So think about the potential possible solutions here. These lines touch here and 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 here on forever. So they have an infinite amount of solutions. The next one only intersect at one spot right here, so they have one solution. And the last ones are example of parallel lines that are never, ever, ever going to touch, so they have 0 solutions. So if there are two equations and the solutions are where the graphs touch or where they intersect, if you want to graph something and look at the picture, remember it has to say y equals or be set equal to 0. If you want to find the solutions in your calculator, you'll go to y equals. After you've put them in y equals form, you'll put one of the equations in y1, one of them in y2, and you'll press graph. You'll see the two graphs, and to find the spot where they touch, you can press second trace 5, enter, enter, enter. Let me show you what I mean. All right, these are both solved for y, so I'm ready to put them in my calculator. I'll put the first one in y1 and the second one in y2. And the blue and the red line is what my graph looks like. Now, I can tell just by looking at it, this point of intersection looks to me over 2, up 1. So I'm thinking that my point of intersection is 2, 1. And remember, these are ordered pairs, these solutions. They're just x's and y's that you can plug in. And if they really are an answer to the whole system, you should be able to plug them in the first equation, make it true. Second equation makes it true. If it works for both, you're in business. Now, your calculator can also help you, especially if it's not as clear where you think there might be some decimals involved. So what you will do is grab your calculator. You'll hit second trace 5. 5 is intersection. You'll make sure that your cursor is right over top of the intersection you're asking about, and then you'll press enter 3 times. Look at the bottom, and it will tell you 2, 1. All right, here's another example. So this one is not solved for y. So the first thing we need to do is get it in a form we can put in our calculator. So the first one, 2x plus y equals 4. Well, we just have to subtract 2x. So this is what I'm going to put in y1. The next one looks like this. I have to put it in y equals 4, so I'm going to subtract x and then divide by a negative. Now, you could put the whole top in parentheses and divide by -1, or you're an algebra 2. I think you know if you change one sign, you have to change them all, so it becomes -2 plus x. That's what I'm going to put into y2. And the graph that you're seeing right here in red and blue is what you will get. They just have one solution where they touch. Looks to me, over 2, up 0. It looks like it's at 2, 0. Now, you could ask your trusty calculator for some assistance. Second trace 5. Make sure the cursor is over top where it intersects and press enter 3 times. All right, now we have a few quadratics, or one quadratic and one linear function. They're both solved for y, so we're going to go put them in one in y1 and one in y2, and then graph them. We can tell that they intersect here and here. Now, it looks pretty clear that we go, back 3 and up about 4 spaces. Okay, so it looks like this one's -3, 4, and this one over 2, down 1. It looks like those are our solutions. If it's not that obvious to you, you can still use your calculator. Second, trace 5, but this time you're going to put the cursor over one of the points of intersection and press enter 3 times. It'll generate one of your solutions. Now you have to find the other one, the other point of intersection. Second, trace 5, put your cursor here, enter 3 times, and you'll get the other solution. Oh my. This one right here. The end.